Welcome to Daily Conversation. This is Mr. K.
This is Eric.
Yeah, today is the 6th of November 2021, and the time now is 6:16 a.m. Well, today is a reading session, and we are going to continue reading the book Eat to Beat Disease. So before we get started, please click the like button and subscribe to our YouTube channel. All right, so here we go. Location. Your microbiome is spread all over, especially on the skin and in body cavities. Health promoting bacteria live on your teeth, gums, tongue, and tonsils, and in your nose, lungs, ears, vagina, and especially gut.
The gut is a long tube, approximately 30 feet long, about the length of two pickup trucks. It starts with your mouth and ends with your anus. In between those ends are your stomach, small intestines, and colon. The colon is one of the population's centers of your microbiome. Throughout its inside, a layer of sticky mucus protects the gut. This mucus lining forms a barrier to keep any noxious substances you've eaten or generated by digestion for the microbiome inside the gut lining. Both the mucus and the lining can be influenced by gut bacteria. Some bacteria actually thrive in the mucus, far beyond a simple digestive container. The gut is a command center for your health that is harmed by the microbiome.
Yeah, which is the fifth line, the first words. Um, yeah, this is pronounced as mucus and you pronounce as mucus.
Oh, okay. Mucus.
Our gut's resident healthy bacteria are put into place before you are born. When I was in medical school, we were taught that the womb of a pregnant mother is sterile, and that healthy bacteria are introduced to a baby only during childbirth as the head is squeezed through the birth canal. The vaginal bacteria are in contact with the baby's lips, and bacteria that will colonize the gut is swallowed. The, the sterile womb idea has been overturned. We now know that healthy bacteria are transferred from the mother to the fetus during pregnancy. Both the placenta and the amina, ami- amniotic fluid in which the fetus floats for 9 months contain bacteria that colonize the developing human that contribute to its microbiome and future health. Of course, during vaginal childbirth, bacteria are also transferred to the baby.
Even after the baby is born, the mother is not yet done shaping the microbiome. Newborns are immediately handed to their mother to establish skin contact and closeness with her. The skin-on-skin time puts the infant in, con- in contact with bacteria. Then breastfeeding further loads the baby with microbes. Once again, modern understanding overturns what doctors were once thought was once taught in medical school when they learned that breast milk is a sterile fluid. Wrong. We now know the special cells from the mom's immune system, called dendritic cells, pick up bacteria from her gut and deliver them through lymph channel to the milk duct of the breast. This means breast milk is chock full of healthy bacteria destined for the infant's gut. In fact, it's been estimated that almost 30% of an infant's gut bacteria comes from its mother's breast milk, 10% comes from suckling the nipples and swallowing skin bacteria, and the rest come from other early exposures to the environment. Since an infant consumes about 27 ounces of milk per day, it's estimated that up to 10 million bacteria are swallowed every 24 hours. Now, think about the potential impact of antibiotics administered to either the mother or the baby during the periods surrounding childbirth. This could diminish critical healthy bacteria in the mother or interfere with their transmission during childbirth and lactation. lactation. Infants who are formula-fed have substantial differences in their microbiome compared to those who have been breastfed for at least 6 weeks after delivery.
Yeah. Let me check one pronunciation.
Infant.
Infant. Yeah. That's quite okay. Yeah. Because I heard that you pronounced this one, which is for example, the third line, the last third word from the bottom. Sorry, from the uh, it is the last third words, uh, third line from the top. Yeah. So this one you pronounce as infant, right?
Mm.
Yeah, and
Infant.
yeah, you're correct. As an infant switches to a solid food diet, the gut flora change yet again as bacterial and prebiotics in food gain entry into the gut. By the age of 3, children have established colonies that will help them defend their health for the rest of their lives. A study of 1,095 ridiculously healthy people who have no health issue or family history of serious disease across all age groups, from age 3 to more than 100 years old, show that a common denominator in both young and old is an almost identical microbiome.
The dilemma of how to use antibiotics now faces the medical community. As a doctor, I know the value of antibiotics and know firsthand the benefits of their judicious use, but our growing knowledge of the microbiomes is teaching us to think about the consequences of killing the good diet. Every doctor saw during their training an infection called difficile, the C called C. Doc. difficile. The C stands for Clostri- Clostridium, which, which it turns out is not a foreign invader, but a part of the normal microbiome. It's one gut's bacterium, however, whose growth needs to be held in check by other bacteria. When sick patients are given antibiotics such as clindamycin, C-dot difficiles can sometimes overgrow and cause an intestinal reel with, with severe diarrhea, fever, cramping, and life-threatening complications like bowel perforations and bleeding. But as we learn how our microbiome defends our health, we are rethinking how changing our gut's bacteria might contribute to the mysteriously increasingly rates of food aller- aller- allergies, diabetes, obesity, cardiovascular disease, cancer, Alzheimer's disease, and even depression. The puzzle is far from solved, but it should make us all the more cautious about the cavalier use of antibiotics and even antiseptic. And it tells us we need to think more about how to keep our gut bacteria in good shape for our overall health. What you eat is one approach.
How your diet affects the microbiome. How the gut microbiome functions is strongly influenced by our diet. Over the course of your lifetime, 60 tons of food will pass through your digestive tract. What you eat also feed your bacteria. Prebiotic foods can improve bacterial function. We can also introduce new bacteria into our ecosystem by eating foods that naturally contain healthy microbes. These can be easily achieved by eating some common fermented foods, as you'll see in Chapter 8. These are probiotic foods. Other foods modify the environment of the gut, making growth of some bacteria more favorable. Throughout our lives, we are constantly introducing new bacteria into our body, even exchanging bacteria with friends and family, which then becomes part of our microbiome. A kiss can introduce as many as 80 million bacteria per smooch, but the most common entry point is through eating. Foods that affect the microbiome are either probiotic or prebiotic. Probiotic foods such as yogurt, sauerkraut, kimchi, and cheese contain living bacteria and thus bring their own bacterial contributions to our inner ecosystem. One renowned cheese illustrates illustrates this effect. Camembert, a soft, creamy, pungent cow's milk cheese made in France. Researchers from the French National Institute for Agricultural Research and the Paris Descartes, Descartes University studied the effects of camembert cheese on 12 healthy human volunteers who who were given 3 dice-sized cubes of cheese, 40 grams, cut from the same batch of cheese, to eat twice per day for 4 weeks. They collected stool samples from the participants once before the study, twice throughout the study, and once more a month following. They examined the cheese sample for microbes and also checked for any changes in the stool bacteria. The researchers found several organisms of note. One of the fungus called geo- geotic- geotrichum, geotrichum, geotrichum candidum that is not normally present in humans, but is found in the starter culture for camembert cheese making. This proves that an organism originating in cheese can make it all the way through the gut. The bacterial leuconostoc mesenteroids used in the starter bacterial culture was also found in the stool, and Lactobacillus plantarum, a bacteria found in both camembert and healthy human microbiome, was increased in the humans after consuming the camembert daily. So not only does eating cheese introduce new bacteria into the gut, but it influences the bacteria already there.
Prebiotics are non-digestible foods that feed the healthy bacteria in our intestines. They themselves are not microbes, but rather they increase the function of healthy gut bacteria by providing the food they need to thrive and, as a consequence, create healthy metabolites or influence the immune system. Typically, prebiotics are dietary fibers which are metabolized by the microbiota to form a number of beneficial metabolites. Notably, the SCFAs mentioned earlier. We will discuss different probiotic and prebiotic foods in more detail in part 2. Other ways that our foods can affect microbiomes is by altering the gut environment so that it's favorable to growing healthy bacteria. Think of bacterial species. Think of bacterial species in the gut as competing sports teams. They are each training and preparing to test themselves against each other to gain dominance. Giving one species the food they prefer can fuel their growth over another team, giving them a competitive edge. Given them a competitive edge, researchers are finding out there's a whole subfield of microbiome nutrition in which the proportions of sugar, fat, and fiber in food can determine which bacteria in the gut win up, becoming dominant.
The last line, the first word, yeah, and you pronounce this word as determined, and the stress should be on the second syllable. So it is something like determined.
Okay, determined.
Small changes in the environment can also favor one species over another. In the tunnel of the gut, the mucus coating is the gut wall is home to some bacteria. The mucus contains a gel-forming carbohydrate that helps it maintain its coating property. This carbohydrate is also used by gut bacteria to metabolize food. Certain foods can affect the mucosal lining and help these bacteria by enhancing their environment. Akkermansia is one important beneficial bacteria in our microbiome that lives and thrives in the intestinal mucus lining. Eating foods that increase the gut mucus, like cranberries and pomegranates, helps Akkermansia growth. These foods will be discovered in part 2.
Microbiome and future generation. At the same time that we are learning about how bacteria inside you influence your health, other research is revealing how your microbiomes can be passed on to future generations as a legacy of the lifestyle we have led. As mentioned earlier, the more diverse the bacteria in our gut ecosystem, the healthier we are. However, scientists from Stanford, Harvard, and Princeton studying diet and microbiome have shown that if we are not careful, the way we eat can actually cause the extinction of some gut bacteria, which can impact on the health of future generations. The scientists conducted experiments with germ-free mice implanted with gut bacteria obtained from a healthy human. This involved introducing fecal matter from a healthy human volunteer into a mouse gut, so the bacteria would colonize the mouse and replicate the ecosystem found in the healthy human gut.
In one study, the scientists switched the diet of a group of these mice from a low-fat, high-fiber diet, resembling a plant-based diet that is healthy for both humans and beneficial bacteria, to an unhealthy, high-fat, and low-fiber diet, Western-like, for 7 weeks. This diet switch changed everything in the microbiome. A whopping 60% of the diverse bacteria that were originally present in the healthy volunteer reacted to the unhealthy diet by reducing their numbers by half. It gets worse. When the scientists switched the mice back to the healthier plant-based diet, only 30% of the decreased bacteria recovered to their previous levels. In fact, the overall microbiome profile remained changed for as long as 15 weeks, about 10% of the life of a mouse afterward. The scientists concluded that some healthy bacteria are resilient and can bounce back from a dietary insult, while others cannot. They call the persistent defect a scar left on the microbiome due to diet.
Here's where it gets interesting in this study. The microbiome scar became larger over generations when the researchers began breeding the mice and exposing each generation of mice to the high-fat, low-fiber Western-style diet, which each generation more and more of the original bacteria from the healthy human disappear from their microbiome. By the fourth generation, great-grandchildren of the original are sobering. 72% of the microbes from the initial healthy mice were no longer detectable. Generations of eating the same unhealthy high fat, low fiber diet killed off healthy gut microbes permanently. They became extinct and could not be regenerated by a healthier plant-based diet as before.
Even in the short term, unhealthy diets wreak havoc, havoc on your microbiome and leave a scar that takes time to recover even after you return to eating a healthier diet. These scars can create serious imbalances in your health because the microbiome is tied to other health defense systems. An unhealthy diet can, by extension, damage your angiogenesis defense, disrupt your stem cell function, make it harder for your body to protect its DNA, and compromise your immune system. This is serious because some bacteria activate your immune defenses to protect against cancer and infections. Other beneficial bacteria turn down the immune response, preventing allergic reactions to the foods that enter the gut. I'll provide more details on these when we discuss the immune system in detail in Chapter 5.
Microbiome and disease. Although modern civilization spent most of the 20th century fighting diseases caused by microbes, in the 21st century we may be fighting disease using bacteria. I began to appreciate the potential of this when I heard a lecture by Susan Ertman, Ertman, who heads up the divisions of comparative medicine at the Massachusetts Institute of Technology in Boston. As co-chair of an annual wound healing conference, I had invited her to present her research on a bacteria called Lactobacillus reuteri, a, spe- a species that is part of the human microbiome. Earthman described her research showing how this bacteria can make wounds heal faster. Her talk was riveting. She presented con- convincing data that L. reuteri, which is found in some yogurts, as a, and as a dietary supplement, could accelerate wound healing in mice if it was put in their drinking water. It also worked in humans when given as a probiotic. Afterward, Edmund and I collaborated on research to understand how these bacteria help speed up healing. The answers: L. reuteri, when swallowed, speeds up angiogenesis in healing skin wounds. Yet another connection was made between the health defense systems.
But wound healing was only the beginning. In the lab, L-reuteri also reduced abdominal fat and obesity in mice. Even they ate a junk food diet of potato chips. L-reuteri can stimulate the growth of thick, shiny, healthy hair, improve skin tone, boost the immune system, and prevent the growth of tumors in the colon and in the breast. And that's not all. Experiments have shown that in male mice, L. reuteri in drinking water increases testicular size, test, testosterone, tes, testosterone production, and mating frequency. A truly fascinating finding was that L. reuteri stimulates the brain to release the hormone oxytocin, which is the social bonding neurochemical that is released from the brain during a hug or handshake by close relationship during kissing, breastfeeding, and orgasm. The depth, the depth of research conducted with this one bacterial is so impressive. It led to an article in the New York Times called Microbes, a Love Story. Needless to say, this is a probiotic worthy of taking because of the scientific evidence for its action and potential benefits.
Microbiome out balance. Dysbiosis is the severe disturbances in the bacterial ecosystem. An imbalance of gut bacteria is linked to diseases as, as far ranging as diabetes, obesity, alcoholism, inflammatory bowel disease, infect, infectious co- colitis, irrita- irritable bowel syndrome, cancer, asthma, psoriasis, multiple multiple sclerosis, Parkinson's disease, Alzheimer's disease, atherosclerosis, heart failure, celiac disease, liver disease, chronic fatigue syndrome, cavities, schizo- schizophrenia, and depression. The exact microbes or mechanisms of micro, microbiome imbalance leading to each of these conditions and whether they are the cause of effect are under investigation by some of the rising stars of scientific research. Meanwhile, the medical establishment is starting to take notice. A once widely used and now banned antimicrobial chemical tri- tri- triclosan, which used to be in toothpaste, soap, detergents, and more than 2,000 consumer products, was, was discovered to disrupt the gut microbiome in the infants and increase colitis as well as tumor development in mice.
Okay, the third line, which is the third word from uh, from behind. Yeah, this is colitis, and you pronounce as colitis.
Colitis,
Yeah, and one more is the sixth sixth line, the second word. Yeah, this one is fatigue, and you pronounce as fact. Uh, yeah, I don't know, but the stress isn't on the second syllable.
can you pronounce again?
Fatigue.
Fatigue,
Yeah. The micro the biotechnology industry is eager to tap into the power of the microbiome. A procedure known as fecal microbial transplantation (FMT) has been developed to treat dysbiosis by replacing unhealthy gut bacteria with beneficial gut bacteria from the stool of a healthy donor. The procedure has been used to treat patients suffering from Clostridium, Clostridium uh, difficile, difficile colitis, often a complication of antibiotic use. As discussed before, although the standard of care is to use more antibiotics to kill C. difficile, infection recurs in up to 60% of people. In those situations, doctors are turning to FMT. A healthy doc A healthy donor is asked to provide a fecal sample, which is mixed with water and then sprayed along the entire inside of the colon by a doctor using a colonoscope, colonoscope. Despite the ick factor of FMT, its proponents claim the procedure is cure, cure, curative in about 90% of the cases after a single treatment. Clinical trials are underway to see if FMT can help prevent or cure recurrent urinary tract infections, chronic constipation, diabetes, os- ulcerative colitis, and even obesity.
The last bit, K is pronounced ulcerative. You pronounce
Oh,
ulcerative.
okay, so is ulcerative.
Uh, but based on the pronunciation you put here is ulcerative.
Oh, yeah,
Ulcerative.
ulcerative.
Some biotechnology companies are developing special formulas of probiotic, dietary fiber, and plant bioactives as a smoothies to promote healthy bacterial regrowth in the gut as a means to treat diabetes, obesity, and other conditions. Other companies are taking a diagnostic approach, offering to analyze your stool and give you a report on your microbiota. A stool test called Smart Gut sequences the DNA of bacteria in your feces and tells you if there are any bad actors and actions to take. A vaginal microbiota test called Smart Genes identifies not only sexually transmitted diseases but 23 types of healthy vaginal bacteria.
Probiotic supplements are touted as an easy way to introduce healthy bacteria in our gut. But despite the massive industry that exists 36 billion in 2016 and expected to grow to 65 billion by 2024. The jury is still out of their efficacy. Probiotic products containing lactobacillus and bifidobacterial, for example, are available at the grocery store and drugstore and through online shopping. The challenge is that most commercial probiotics are not that well studied compared to the foods you will learn about in Chapter 8. Generally, however, they are accepted as safe in people with healthy immune systems and potentially helpful for ameliorating, ameliorating diarrhea and other digestive dis- disturbances.
Diet may well be the most powerful tool for influencing our microbiome. Natural foods offer a more diverse source. For instance, yogurt, fermented foods, and some drinks are loaded with bacteria. But even when you aren't directly consuming probiotic material, what we eat has the most profound day-to-day effect on our microbiome defense system. Our diet can shrink or expand the different population of gut microbiota on an hour-to-hour basis. The food you eat affects your gut's ability to heal, sometimes in surprising ways. In part 2, I will tell you how eating different types of foods can interact with and build your microbiome for the better. For example, you can influence the population of one particular kind of beneficial bacteria in your gut, which in turn has been shown to make some cancer treatments more effective.
But first, I want to share with you another powerful defense system your body possesses to keep you healthy. The body's mechanisms for protecting your DNA. Yeah, so we stop here.
Mm,
All right, so how about I make a summary?
okay.
Yeah, for today's part, firstly, talk about location and which is where's our microbiome. And microbiomes are almost uh, over all our body. Yeah, and then they can be found in skin, teeth, maybe tongue, and then our nose, our lungs, ear, vagina, and gut. And the last one, gut, which is actually something to be mentioned, especially because this is one of the center of where the microbiome live in. And then um, yeah, from the mouth to the anus, yeah, and then our gut is actually very long and is approximately equal to two trucks, the length of two trucks. So um, between these, the colon, yeah, which is the central of the microbiome, yeah, and then this is the first part, and then talk about where's our microbiome is basically in, and the majority of microbiome, and the second part, talk about when our microbiome exists. And for this part, microbiome actually started to take place when we are still a fetus. We are still in our mother's womb, and then after we were born, and then yeah, uh, also during the process of born born, and then after and also after born, uh, we keep getting bacteria. Yep, and then this kind of bacteria can be like skin contact, and then it can also be the breast milk feeding, and then also subject to a little about the environment. Yep, and then also this actually uh, highlights something which is the breastfeed, the breastfed baby, and also compared to those formula fed baby, they can have a difference between them because the breast milk feeding for that process, not only the milk but also the skin contact, is actually delivering bacterial to the baby. Of course, these kind of bacteria are mostly good and healthy. So yeah, so I think um, this is something that can explain the benefits of breastfeeding. Yep, and then also there is a part talk about antibiotic. For this one, it mentions that even if the pregnant mother uh, take the antibiotic, and the antibiotic actually kill the bacterial, either is healthy or bad one in our body and altogether. So it can affect not only the mother's health, but also the baby inside, the fetus. Yeah. So also the author as a doctor also concerned about the use of antibiotics, and then also this kind of antibiotic actually affect the gut bacterial, because the bacteria are mostly, I mean, the majority of the bacteria, the microbiome is kept in our gut, and this kind of antibiotic can affect the maybe the balance of the microbiome inside our gut, and maybe they will have some effects to other diseases, which is like those chronic diseases, or maybe cancer, uh, yeah, that kind of diseases. But also the author says that this is something like a question marks and haven't been solved. Yeah, and then also not only antibiotic, also for antiseptics, which is those maybe those things we use to clean our hands, or maybe we used to clean, we used to sterilize maybe our personal things. So that kind of antiseptic is also one of the things to be considered, because it will kill the bacterial, uh, either healthy and bad one. Yep, and also for this one, when I was checking dictionary, yeah, this is some sharing, which is antiseptics. One of the meaning of antiseptics is not something like we use to kill the bacteria. It can also it has another meaning, which is in Chinese we call 防腐剂, yeah, which is we put in the food and then to keep the food from getting rotten soon. And so this is the first time I know that actually uh, this kind of food antiseptic is functioning as a way to like to kill the bacteria. So it is like the antiseptic. Yeah, and if we consume something with antiseptic, maybe it will affect the microbiome in our body. But this part I am not very sure, because I just think by my own. And okay, so go back to summary, and then after that, we can talk about the diet and microbiome. And in this reading part, we saw two words quite frequently, which is prebiotic and probiotic. I think maybe they are different, but they are kind of similar. And then both of them improve the bacterial function, and then we consume some foods that contains prebiotic or probiotic. Is something like some a portion of the food cannot be uh, they are non-digestible. Yeah, and then this kind of non-digestible food actually feed the bacteria inside our body. Yeah, so they are good for microbiome. And then this is uh, the first part of this diet and microbiome. And the second part of diet and microbiome can be, just now we talk about prebiotic and probiotic improve bacterial function. So it's like to help the bacteria inside our body. But the second part can be some other food which is fermented, which is like something like the kimchi, the cheese, or yogurt, something like that. So those kind of food, not they're not only helping the bacteria inside, but actually uh, uh, they are introducing new bacteria into our bodies. Yeah, and then we have the third part, which is there are something which we can eat, and then that help to alter our gut environment. Is like um, to help to fix the environment so that the bacterial inside can also function well, something like that. So they are the mucus in our gut, which is kind of like a gel form of carbohydrate, and this kind of gel form carbohydrates actually helps to metabolize food. Yeah, so these are three parts in diet and microbiome. Yeah, and next one talk about the lifestyle and microbiome. Yeah, interestingly, actually, I think I heard about this before, which is like when people kiss and then we actually exchange bacteria. Yeah, but once again here, it make me more impressive. Yeah, which is one kisses equal to like I forgot, maybe it's like 80 million of bacterial exchanges, just one kiss. Yeah, so this is kind of interesting. And then also some other uh, um, oh yeah, so this is the part for lifestyle and microbiome. And also there was one experiment talk about the mice, and then for this environment, it want to prove that uh, the diet we eat, and then it can affect the microbiome in our body. And also in the experiment, uh, there are two group of mice, and then one group eat those kind of low fat, high fiber diet, and the other one take high fat, low fiber diet. And after the experiment, and the result shows that uh, of course, if is the group that consume low fat, high fiber diet, uh, mice, they can actually maintain the good bacteria which is put inside the body before the experiment, so they can maintain it well. And then for the other group, which is consuming high fat, low fiber diet, actually their bacterial, the microbiome kind of like are damaged. Yeah, and then the bacteria reduce, yeah, the healthy bacteria reduce, and then also they try to switch back the diet uh, from an unhealthy one to a healthy one, and found that even after a few weeks and few months, those good bacteria cannot be completely recovered. Yeah, so this is, I think, is a very good experiment, and to warn us that to eat healthy diet, and some of the bad things that we eat, the unhealthy things, those unhealthy diet we consume, actually affect us in the long term. Yeah, we couldn't like uh, um, recover from that completely. Yep. So yeah, I think these are my sharing today.
Mm. In this reading session, I want to uh, make a point of, uh, about the summary, which is
Mm.
one of the data that impressed me, which is uh, through the kissing and uh, actinium, actinium of the oral microbiomes uh, will be passed, will be exchanged.
Mm.
So yeah, so I try to check whether this information is reliable, and
Mm.
I try to check like touch keys increase microbiome, and
Yeah.
it seems like is it true? And yeah, through the kissing, active median bacterial still with the key. So 80 million of the good bacteria, the microbiomes, uh, can exchange between the partner.
Mm.
Yeah. So yeah. Uh, so from this, first we know that first is microbiome cannot not only can obtain from foods, from medicines, and also can obtain from other humans, from your
Mm.
partners,
Yeah.
because
Okay.
uh yeah when the microbiome can spread, can exchange between two people, and it actually can kind of like to activate the growth, to 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 s- to stimulate the growth of microbiome. Yeah.
Mm.
Of course, here we didn't talk about uh, maybe some of the bad bacteria can also be exchanged
Mm.
during the kissing, and
Yeah.
and one of the search I found, which is also uh, quite interesting, which is kissing your dog could improve your health. It's
Mm.
also, yeah, it's also like kissing your dog can exchange, can increase the microbiome.
Mm.
Uh, yeah. So yeah, this is one of thing.
Mm.
And okay, and the research I found that is quite reliable because the research is from the U.S. National Library of Medicines, which and National Institutes of Health. So it is quite reliable,
Mm.
and it also mentioned that through the hugging, to the hugging and kissing, and the frequency and uh, intimacies of which increase. Yeah. So um, from through the touch and also the kiss and also hugging, and maybe also like uh, uh, making love with your partner can also increase the microbiome. Yeah. So this information is quite reliable because the article is written, and the data and the information is searched from a government website. Yeah.
Mm.
So, and it lead to 2 points make me think. Yeah. The first is about uh one of the topic we discussed in before, which is how to live longer, and also one of the topic in the past, and I mentioned about the marriage people have low mortality rate than than single than unmarried people. So
Mm.
yeah, and also we can, and because there's something is correlated to this, which is married people uh have more frequency of making love, have more frequency of touch each other, have more frequency of kissing each other
Mm.
compared to single. Yeah. So this means, mm, if if we try to correlate, yeah, of course, maybe there's no maybe the relation is not strong, but there is something that can support the res- the statistic, which is unmarried people have higher mortality rate than married people. So this means, um yeah, so uh microbiome microbiome can biologically increase your longevity. Yeah. So
Mm.
this is one of the uh one of the founding or one of the conclusions get from logic. Yeah, and
Mm.
and also the second is uh, through the last it's actually from last reading sessions, and this is about micro we read some part which mentioned that microbiome can affect our emotion, can affect our moods, can
Mm.
like uh, activate and stimulate our brain to release some chemical and make us feel happy,
Yeah.
or make us feel uh, less stress. Yeah, and yeah, also there's some other research which I learned from positive psychology, and through the hugging, uh, through the hugging and through kissing, through the touch, can actually increase the long-term happiness level. Yeah, so that means something that is not only affect our mental, it
Mm.
also can affect it also can affect us biologically.
Yeah.
Yeah, so so this is something that I learned from this reading session. Because it seems like many of the things can link together,
Mm.
and some benefit we think is mental, but it can also through the biology. Mm,
Yeah.
yeah. Okay. So do you have anything want to add in?
Yeah, I think no. And thank you for your research.
Mm.
Yeah.
Okay. So that's all for our today conversation. How did you feel? Did you enjoy the conversations? Please tell us what you think about conversation. And we are not native speakers. If you found any vocal mistake that we made, please also comment to let us know, because we want to learn more and improve ourselves. Remember to like, subscribe to us. Thanks for watching. See you tomorrow.
See you tomorrow.